6.4 is solving systems of equations that are actually word problems. So here's an example, and you can use any one of the methods that we've learned to solve them. Mary has $10 in her savings account, and Sarah has $6 in her savings account. Mary saves $2 a week from her babysitting job, and Sarah saves $4 a week from her newspaper job. After how many weeks will Sarah and Mary have the same amount in their savings account? So first we have to come up with some variables. So looks like we started out with some amount, and then to that amount, here's $2 a week. So that's every week she adds $2, and Sarah every week adds $4. So we need to know something about how long they're keeping it in there. So let's have W equal weeks. And we're trying to figure out how much they saved total. So let's have S equal savings. Now, let's look at Mary. So Mary has $10. She started with that $10. It doesn't matter how many weeks we go, that $10 is still there. So here I'm going to do Mary first. And Mary has that $10 in there. That $10 doesn't change, so plus $10. But Mary saves $2 every week, so that would be her savings would equal $2 a week plus the $10 that she started with. This is Mary. And Sarah's savings would be $4 per week, plus she started with $6 in there. So now here's our two equations, and we want to see when they have the same amount. So when S is the same in both of them. So I want to know when S is equal, when these two things are equal to each other. Well, I am going to plug this in because I said S is that for the S in Mary's. And I would rewrite as 4W plus 6 equals 2W plus 10. I have to get my W's on one side, so I'm going to move these W's by subtracting. And we have 2W's plus 6 equals, these are gone, 10. And now I still have to get W by itself, so first we add or subtract the numbers. So minus 6, we have 2W equals 4. If 2W's equal 4, I divide both sides by 2, and you get W equals 2. So in 2 weeks, that means 2 weeks is when they will have the same amount. So let's just check that and see if it works. So I'm going to plug 2 in. So Mary said savings equals 2 times W, which is 2, plus 10. So we're saying S is 4 plus 10, or 14. So S equals 14. Let's try it in the other one and make sure S equals 14 in the other one. So Sarah, we said S equals 4 times W plus 6. So this is 8 plus 6. That is equal to 14. So we have a match. So in 2 weeks, they will both have $14 in their equation. They both have $14. All right, so let's try another one. A snack bar sells 2 sides of snack packs, a large pack for $5 and a small one for large, let's see, for 5, small for 3. In one day, the snack bar sold 60 snack packs for a total of $220. How many snack packs did the snack bar sell? In one day, the snack bar sold 60 snack packs for a total of 220. Huh. All right, so they sell 2 sizes. So let's say S equals small and L equals large. And I think what the question is, how many of each size snack packs did we sell? That's what we want to know, because we know we sold 60. That was one of the things. But so let's write our equations. So a large, let's see, so they told us our first equation has something to do with how many snack packs we sold. We sold 60 of them. That's when I add up all the smalls plus all the larges, I got 60. That's one of my equations. Then there's something else that talks about money. So there's the other equation that talks about money, and it says a large snack pack costs $5. So $5 for every large plus $3 for the smalls has to equal my total amount that I earned, which is $220. So this time I think I'm going to do by, last time we did by substitution, let's do by elimination. So I'm going to multiply this whole equation by -3 because I want to get rid of my, whoops, I actually don't want to do by -3 because I notice, first I'm going to reorder it as L plus S because that's how it's written in this one, L plus S equals 60. I want to cancel out my S's, so I'm going to multiply this whole thing by -3. So I'd have -3L plus -3S equals -180. So let's write that underneath my first equation. Hold on, I'm going to erase this. And you get so I'm going to add up my L's. I have -3 and 5, so I have 2 L's. My S's disappeared, equals 180 minus 220 minus 180, so that'd be 40. So L is going to be half of 40, which is 20. If I plug that back in, here I have S plus 20 for large equals 60. What plus 20 is 60? I know S has to be 40. Now let's just try it in the other equation and make sure it really works. The other equation was the one with money, and it said $5 for every large, so 5 times the 20 larges, plus 3 times the 40 smalls has to equal $220. So let's see if that works. 5 times 20, 100, plus 120. Is that 220? It is, so we are right. So the question was, how many of each size did we sell? We sold 40 smalls and 20 larges. And 20 large. So 40 smalls and 20 larges is what we sold. Okay, you pay $22 to rent 6 video games. The store charges $4 for new games, $2 for old games. How many new games did you rent? So there's 2 different things again. One's all about the money, one's all about the number. So I know that we had old, I don't want to call it old, so let's just have X be old games. And let's have Y then be new games. I didn't want to do O because O's look too much like zeros. But let's just talk about games. We rented all together 6. So my old games plus my new games has to equal 6 games. Then I'm going to do something that talk about money. I paid $22, so it has to equal 22. And it says $4 for new. So I'm going to put that under the Y. 4 for new. And 2 for old. So $2 for old games plus $4 for new games equals $22. So right now, if I just add them together, I'm not going to get rid of one. But if I multiply everything in this top equation by a -2, I know I can get rid of the x's. So I'm going to do that. That would be -2x. -2 times y is -2y. -2 times 6 is -12. Now I can add these 2 together. My x's disappear. I have 2y equals 10. Divide by 2. So y has to be 5. So 5, I borrowed 5 new and if I plug this 5 in to my first equation, I would have x plus 5 equals 6, and that would be x would be 1. So 1 old 1. So answer is I borrowed 5 new and 1 old. We could check it by plugging it in here. So I'm going to go right up here. It says 2 times x, so 2 times the old, which is 1, plus 4 times y, which is 5. Is that 22? That's 2 plus 20. That does equal 22, so there's my check, and we are right. All right, I have $3.70 in dimes and quarters. I have 5 more quarters and dimes. How many quarters and dimes do you have? So again, one that talks about dollar amount, and one that talks about just how many I have. So I'm going to have D equal dimes and Q equal quarters. And it says, let's see, I have 5 more quarters than dimes. So quarters equals 5 more quarters than dimes. So dimes plus 5. So if I have 1 dime, I have 5 more than that quarters, right? 1 dime, 6 quarters. So that's what my one equation is. Quarters equals dimes plus 5, because I have 5 more of them than I do dimes. The other equation is going to be something about money. So $3.70. So what's the value of a dime? It's $0.10, right? 10 cents. So 0.10 times the dimes plus 0.25 times the quarters has to equal $3.70. So I'm going to use this time, since I have Q equals D plus 5, set a Q. I'm going to put in D plus 5. So I have 0.10 D plus 0.25 D plus 5 equals $3.70. I have to distribute this 0.25, so I have 0.10 dime plus 0.25 D plus, then I have to take 5 times 0.25, which is $1.25 or 1.25. Right, I'm distributing this, equals 370. I have like terms. 0.25 plus another 0.10 is 0.35, and you should be using your calculator. If you're not, if this doesn't make sense, you can just do it on the calculator. Plus 1.25 equals 3.70. I have to get the D's by themselves, so I'm going to minus this 1.25. And I get 3.7 minus 1.25, which is 2.45, equals 0.35 D. I have to get rid of a number in front of D, so I divide by 0.35. And 2.45 divided by 0.35 is 7. So D is equal 7. And it says on our first equations, which are way up here, so I'm going to just write a 7 here so we know that there's 7 times. To figure out how many quarters, I'm going to plug that 7 in right here. So quarters equal 7 plus 5. So quarters are 12. Now let's see if it works in our dollar amount. So we have 0.10 times 7 plus 0.25 times 12. And we want to know, is that $3.70? So this is, if you have 10 dimes, you have 70 cents, right? So 0.7. If you have 12 quarters, that's $3. Is that $3.70? It surely is, so that's our check. The length of a rectangle is twice the width, and the perimeter of the rectangle is 30 centimeters. I'm going to draw the picture. So here's the width. It says the length, so this side, is twice the width, 2 times the width. And the perimeter is 30. What's the length and the width of the rectangle? Remember, perimeter is adding up all the sides. This would also be a 2W, and that would be a W. So now I have all of these things in terms of W. So L equals 2W as one of our equations. I'm going to add them all up, and that's my perimeter. So I'm going to say 2W plus W plus 2W plus W, and that has to equal the perimeter, which is 30. So 2, 3, 5, 6 W's equals 30. Divide by 6, and you get W equals 5. Well, if W is 5, I'm going to plug it back in there. So L has to be 2 W's, or 2 times 5. So L is going to be 10. So the length is 10 centimeters and the width is 5 centimeters. That is all for this lesson.